We now discuss the solution of a problem which is based on the area of a given region, and this question is from the integral calculus. This question has appeared in the joint entrance exam main held on 27th June 2022 in the second shift. The given question is, if the area of the region, the set consisting of ordered pairs x comma y, such that x to the power of 2 by 3 plus y to the power of 2 by 3 is less than or equal to 1, and x plus y greater than or equal to 0 and y greater than or equal to 0 is capital A, then 256 times A by pi is equal to. So we are given this region and we have to find the area of this region, that is capital A, then required to find the value of 256 times A by pi. So we find the area capital A of this given region and required to find 256A by pi. That's the given question to us. Let's now discuss the solution of the problem in detail. So let us first of all get familiarized by this curve. The equation x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to 1. This curve, this represents a continuous closed curve. It may be seen that it is symmetrical about both the axes. So if you substitute minus x for x, this remains same, and substitute minus y for y, this equation remains the same. Therefore, it is symmetrical about both the axes. This intersects the x-axis at plus or minus 1 comma 0 and the y-axis 0 plus or minus 1. The y-axis at the points 0 comma plus or minus 1. And this curve is famously known as asteroid. This curve is known as asteroid and is shown in the diagram. This is the one, and I will show you in a magnified fashion. So this is the curve. Agreed. Now let's move to the next slide. Now the region, what is given to us, is the set of all ordered pairs x comma y such that x to the power of 2/3 plus y to the power of 2/3 less than or equal to 1. So this will give you all points that lie on the asteroid and inside the asteroid, comma means and x plus y greater than or equal to 0. That means y is equal to minus x. Y greater than or equal to minus x means take the line y is equal to minus x, and all those points that lie above the line y is equal to minus x intersect with all the points that lie inside and on the asteroid. Not only that, and y greater than or equal to 0. That means all points that lie above the x-axis above the on the x-axis and above the x-axis, and intersection of all these three is the region, and it is shown in the figure. Let's get into the picture. So that's our asteroid. All points that lie inside and on means here. So let's take y is equal to minus x. This is y is equal to minus x. And x plus y greater than or equal to 0 means y greater than or equal to minus x. That means all points lie above this line. And common to all points that lie inside and on the asteroid. So what is common? This portion, and this portion. But now y greater than or equal to 0. That means all points that lie on the x-axis and above the x-axis and common to all the three. Then common to all the three will be this portion and this portion. Now it is shown here. This is the region, shown with a blue horizontal lines, shaded by the blue horizontal lines, and this portion shaded by the red vertical lines. So this portion. So this portion plus this portion. You can see it in a magnified way. So this is the portion. So this one. So the area, the region is this one. The area of this one you have to find. Agreed. Now A is equal to area of the above region. That is equal to area A prime of the region with the horizontal blue bars. So this one, horizontal blue bars, and plus the area A double prime of the region with vertical red bars. These are the vertical red bars. Agreed. Now, because of the symmetry, the area of this one, that is the area of A prime of the region with horizontal blue bars, this one is same as this corresponding portion in the second quadrant. They are equal, and this line bifurcates, bisects this one and makes equal areas. So this A double prime is half of this one, which is half of A prime. So notice that A double prime is half of A prime, since the curve is symmetrical about y is equal to minus x. Agreed. So therefore A is equal to A prime plus A double prime is half of A prime, that is equal to 3 by 2 times of A prime, and A prime means the region with the horizontal blue bars. So for that we have written 3 by 2 integral 0 to 1 y dx. With the horizontal strips we integrated. So integral x varies from 0 to 1 and they are going like that. So y dx. And what is y? Take the equation of the asteroid and solve for y. So take the equation and solve for y. You will get 1 minus x to the power of 2/3 whole to the power of 3 by 2. So substitute here 3 by 2 integral 0 to 1 minus x to the power of 2/3 whole to the power of 3 by 2 dx. To evaluate this integral, we substitute x is equal to sine cube theta, then differentiating dx is equal to 3 sine square theta cos theta d theta. Because this is a definite integral, the limits will also change. Now, when x is equal to 0, theta is also equal to 0. When x is 1, sine cube theta is 1 and theta will be pi by 2. So the integral 0 to 1 will change to integral 0 to pi by 2. So the area A is equal to 3 by 2 times integral 0 to pi by 2, 1 minus x is sine cube theta, x to the power of 2 by 3 is sine square theta. So 1 minus sine square theta whole to the power of 3 by 2 into dx is 3 sine square theta cos theta d theta. 1 minus sine square theta is cos square theta. Cos square theta to the power of 3 by 2 is cos cube theta, and this will be equal to 3 sine square theta cos to the power of 4 theta. So that will be equal to, and that 3 has come out 9 by 2 into integral 0 to pi by 2 sine square theta into cos to the power of 4 theta d theta. We recall this is a integral. We know a formula for that. When m and n are both even positive integers, 2 and 4 are even positive integers, then the integral 0 to pi by 2 sine to the power of m theta cos to the power of n theta d theta is equal to, first take this 2. 2 means 2 minus 1 by 2 plus 4. That means 1 by 6. Then come to 4. 4 minus 1 by 6 minus 2. 4 minus 1, that is 3 by 4. From 3 subtract 2, 1 by 4 minus 2, 2. So that's what it says. This is equal to 9 by 2 into 1 by 2 minus 1. This is power 2 minus 1 by 2 plus 4, 6. So take the 6 as your starting point. Go to 4. 4 minus 1, 3 by 6. From 6 subtract 2, 4. From 3 subtract 2, 1. Then from 4 subtract 2, 2 into pi by 2. So this is the formula which we have executed here, and when simplified it will be 9 pi by 64. Thus we got the area capital A. Required to find 256 times A by pi, that is 256 by pi into A, that is 9 pi by 64. Pi cancels, 64 4s are, 4 9s are 36. So the answer to this question is 36. That is the detailed discussion of the solution of the problem, which is based on computing the area of a given region from the section integral calculus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.